Scientists are in the process of creating a digital twin Earth, with the main idea that if we can simulate everything, every tree, every ocean current, every building, then we can essentially predict the future. As much as I want to disagree with Elon Musk that we're living in a simulation, this really isn't helping.
Please, sir, not in the Matrix. You shouldn't put people in matrices.
And this isn't even some sci-fi idea cooked up by backyard scientists wearing tinfoil hats. The UN, NASA, and probably most importantly Nvidia, since it has a market cap greater than the GDP of most countries, are actively working on making this a reality. Hi, I'm Angus, evolutionary biologist and educator, and today we are going to be investigating digital twin Earths, what they are, and how they could transform the future of species and habitat conservation. So a virtual twin is basically a digital representation of a real-life process so that we can model physical processes in an environment in which failure doesn't matter. The first recorded use of a digital twin was actually in the 1960s when NASA was using it in order to test out the ways in which Apollo 13's oxygen tanks might fail. Note that Apollo 13's oxygen tanks did end up exploding 2 days into the mission. Despite that early ironic setback, digital twins are still widely being used by companies such as Nvidia in order to train robots in digital classrooms. They can virtually try things, fail, and learn millions of times faster than they would be able to if they were doing it in the real world.
They're fake people, but their pain is real. Does that make sense?
The idea of a digital twin Earth is essentially that, except at the scale of the entire world. This is made possible by combining vast amounts of data with physical laws processed by artificial intelligence, machine learning algorithms, and just vast amounts of computing power. The main reason that we're doing this is in order to be able to predict climatic events that occur as a result of climate change, such as droughts or hurricanes, and also to be able to test what-if scenarios. So we'll finally be able to test if a butterfly flaps its wings in Ecuador, it'll cause a hurricane in Uruguay thing is a load of shit or not.
Butterfly, butterfly.
This also touches on a topic called biological determinism, which is why scientists like Robert Sapolsky believe that free will doesn't exist. But that's a video for another time, and let me know in the comments if you want to hear about that. So since we only ever think of ourselves, this technology is mostly designed to save lives or something. But as a biologist, I'm more interested on the impact that this will have on research and ecology, since climate change is dramatically changing the habitats that species can exist in. Now, habitat shift due to climatic change is a natural thing. I mean, Antarctica used to be a tropical paradise. However, extinction risks are not due to environmental change necessarily, but rather the rate of environmental change. In fact, we are actually in the middle of a mass extinction event with extinction rates roughly about 1,000 times higher than what they should be. Scientists have called this the Holocene extinction, or the 6th mass extinction, which officially beats Highlander 2 for the title of worst sequel of all time.
MacLeod, you created that monstrosity. Why?
So if we want to stop this from happening, we have to shift our approach from focusing on where species can survive now to where species will be able to survive in the future. And that's where digital twin Earths can come in. Oh, guys, if you're enjoying this, don't forget to like and subscribe. So a couple of years ago, I published a paper using a technique called species distribution modeling, which basically looked at how the habitat and range of different species had changed and fluctuated since the last glacial maximum about 20,000 years ago. Basically, if you know where a species exists now, like the actual coordinates of where you find them, and you are able to figure out what kind of habitat they enjoy, and you can do that by looking at the bioclimatic variables that you find in each of those locations. Bioclimatic variables are things like average rainfall, minimum temperature during the winter, maximum temperature in the summer, that sort of thing. You can use math to create a model that will allow you to predict where those species are able to survive. This isn't terribly difficult to do, and it's frequently used for a number of different applications like predicting invasive species or rewilding or targeting areas for conservation. It also helps you to identify areas that are known as refugia. These are areas that for one reason or another have stayed climatically stable over long periods of time. They're like mountains or river valleys, and allows you to prioritize conservation efforts to make the biggest impact within a limited budget. So how could digital twins change the face of conservation? Well, systems like the, hold on a second, Destiny Digital Twin for Climate Change Adaptation, or Climate DT to its friends, can project climate information at scales between 5 and 10 kilometers all the way up until the year 2050. Now that might sound like just around the corner, but shit will well have hit the fan by that point.
You're gonna see some serious shit.
So these machine learning algorithms could be able to predict complex interactions, nonlinear patterns, feedback loops, such as the impact that deforestation will have on the climate, and then how that can impact species, and then how that can then impact deforestation. Also, traditional species distribution models are largely based on year-long averages rather than fluctuating changes. This helps us with the issue of migrating species like birds and whales, because just because they existed somewhere at a certain point in the year, it doesn't mean that that's always going to be their habitat. I can totally relate. I mean, Cape Town is amazing during the summer, but during the winter it becomes this gloomy, cold, miserable mess, and no matter what my location data says, is definitely not my natural habitat. So there you have it. While digital twins aren't a solution to climate change, they are a tool that'll help us to predict upcoming changes, which will save both human and animal lives in the process. They're a step in the right direction, and I also just think that they're really cool, which, with regards to my approach to YouTube, is ultimately what matters.
I just think they're neat.
So drop me a note in the comments if you have any other questions, or if you want to have a further video made on any of the topics covered in this video. Also, it was brought to my attention that my last video had a typo in which it made it seem like Gregor Mendel was 2 when he died. So no, that is not correct. Just to clarify, he was born in 1822, and thanks to Carol Higo, congratulations, you are now officially the proofreader for all my videos. So well done. Right, with that out the way, I'm going to give this video the good old I'm done knee slap. See you next time.